Hello guys, so today we are going to discuss this problem, implement stack using queues. So the problem goes like this, that we have to implement a LIFO stack, that is last in first out, using two queues. The implemented stack should support all functions, that is pop, push, top and empty. And we have to implement a MyStack class that is having push, pop, top and empty methods. So before going ahead, let me just discuss that what is a stack and what is a queue. So stack is something like this. So here in stack, uh, if we insert one, so it will be here. If we insert two, it will be here. And if we insert three, it will be here. So insertion always takes at top. And if we now remove, that is the insert operation, uh, insert is called push and remove operation is called pop. So pop always happens from top. There is only one end. So if we say pop, so it'll remove three. Then the stack will have one and two. If you again say pop, it'll remove two. And now the stack will have only one. And now if we say push, let's suppose four, so it will be pushed here. So this is a stack and this is a queue. So queue is a form of a queue, like we have a queue on a bus stop. We insert from here and we remove from here, right? So this is remove, or we can say pop of the queue, and this is the insert of the queue, or we say push of the queue. So here, if we say we uh, push one, so one will go here. If we say push, okay, let me draw. If we say push one, one will go here. If we say push two, two will go here. If we say push three, three will go here. And then if we say remove, so one will be removed. But if we consider the case of a stack, so if we say pop, then in that case the three was the answer. But in that case, in this case, one is the answer. So this is a basic difference between stack and queue. So the question says is that we have to implement a stack, that is this, using queues. So this is a stack and this is a queue. This is a queue. So how we are going to do it? Uh, so we are going to take, so question has told that we have to take two queues, but we are going to take only one queue. So let's suppose we take on this, and so this is a queue. All push operations will happen here at end, and all pop operations will happen here. So for example, we insert one, so one will come here. We insert two, two will come here. So and we insert 3, 3 will come here. So now if we do a pop, 1 will be the answer, but the actual answer should be 3. So what we'll do is, whenever we'll insert a element in the queue, we will move it to the back. So for when the element is 1, it's already back and front are same, so we'll not do anything. Now let's suppose we insert 2. So what we'll do, we'll remove this element and we'll insert it back. So the queue becomes something like 2 and 1. So now in this case, if we say pop, so our answer is 2, which is same as a stack. And if we say push, so push is already, it's fine, right? And now if we insert 3 in the queue, so let me draw it here. So we have 2, 1, and we insert 3. So again, we on the push, we do the same operation. We'll like forgiving the last element, not considering the last element, we'll move all the elements which are there in the queue to back. So here what we'll do, we'll remove 2 and we'll move to back. So it will become something like this. Then we'll remove 1 and we'll move to back, right? So these two elements are removed now and the queue becomes this. So now in this case, when we'll do a pop, the answer will be 3 and it will be a O1 operation because we have to only look at the front of the queue. And yeah, so again, if we do pop, the answer is 2 because it's same as a stack. So the push, pop, empty, and top. Top will be also the O1 operation. So yeah, this achieves our goal. So let's go to the code and check it. So I have implemented using Go. So in Go, we do not have a queue container directly. That is queue data structure we do not have in the standard library. Rather, Go provides in form of a slice. So slice is something as a dynamic array. If you are coming from C++ background, it's same as vector. If you're coming from Rust, Rust also has a vector. In Python, it has the slice again. So here we have a class. So in Go, struct and class both are the same, which have one member variable, which is a slice of type int. Now, when we are doing push here, so what we are doing is we are appending x to the queue. So using this pointer, we are accessing the element of the structure and we are appending x to the queue. So in Go, we do not use dot append on the data structure. Rather, we use append and we pass the data structure and the element. Now what we are doing, we will be iterating from element 0 to element -1 because the last element we have to forgive, like we have to bring it on top. And what we are doing is we are appending the first element q0 into the queue and we are resizing the queue. That is, we are removing the first element. So this is a slice which goes from 1 till end and we are assigning it to queue. So the first element in the queue is appended at back and is removed from the front. And similarly, we are doing it till the last -1 element. And in pop, what we are doing in pop, we have to return the element. So here, if we see in pop, we have to remove the element on the top of the stack and return it. So we are just storing the top element or the first element in variable a. Then similarly, we are popping the first element. That is, we are storing this queue is equal to from 1 to end, and then we are returning a. That's fine. And then the top element is the 0th element. We are returning the same. And for empty, um, Go has a len method which takes the data structure inside. So if length of queue is 0, then in that case we'll return true, that is it's empty, otherwise we'll return false. The time complexity of top pop is O1. The time complexity of push will be O of n-1. If we have n elements, so in that case we'll be having this time complexity. So thanks a lot. Have a good day. And the space complexity for this algorithm will be O of n, the number of elements on the queue. Thanks a lot. Bye.